Let's get started. Hello, everybody. Welcome to OpenCV weekly webinar. And this week, it's just me giving a tutorial on DepthAI and stereo vision. And with me is Phil Nelson, who is the content manager at opencv.org. Phil, welcome.
Yeah, thanks again for joining us, everybody. Unfortunately, we had a cancellation this week. It happens, but the show must go on. And Satya is stepping up to the plate here with a DepthAI tutorial for beginners, which I think is going to be really interesting. I'm actually excited to show it to my nephews when we're done here. So,
all right. And, as always, we will have a trivia question. And this time, the answer of the trivia question will not be in the webinar. It is going to be logic-based, but it is not going to be in the, I'll not mention it, the answer in the webinar. And it will be, not one word, but maybe a phrase or so, right? So I'll ask something like to explain why such and such phenomenon happens, and it will take you about a sentence to explain it, right? So that will
and
make
of course, we'll also be taking a Q&A during the show. Please use the Zoom Q&A to ask your questions. Given the nature of today's show, I'll try to, pepper them in as we go to, as in context. We don't necessarily need to wait until the very end here. So please participate. Thanks for joining us.
All right. And the winner will get OpenCV AI Kit with Depth Lite, OGD Lite, and we are running a Kickstarter campaign for this. You can, the person who wins this will receive it along with our Kickstarter campaign backers. So that's a caveat. It may take a few months. All right, so let's get the winner of this question. Whoever answers the question correctly will get this
OpenCV AI Kit Depth Lite.
All right, so let's get started. Phil, feel free to ask questions. We have more time than usual this time. So let's get started. So you guys can see my screen?
Looks good.
Okay. 1 second, let me arrange a few things. Okay. So DepthAI, well, okay. DepthAI, what is DepthAI? DepthAI is basically the Python API. It is also in C++. It's the C++ and Python API that we use to program OpenCV AI Kit. It works for, OpenCV AI Kit, OpenCV AI Kit with Depth, with OGD Lite, all of them, right? It's the same API, but depending on whether your OpenCV AI Kit has Depth version or not, parts of it may not work. So this code that I'm going to show you and the pipeline that I'm going to show you will definitely work on OGD and OGD Lite, also on OGD PoE, which is the Power over Ethernet version, the more industrial version of OGD.
I think it's the coolest looking one personally.
That's right, and it's also waterproof and things like that, right? So it helps to have it for people who are building. So the presentation, it's going to be a very short presentation. We are going to go over the DepthAI pipeline, what it means. I will explain the concept of a node in a pipeline, and then we will access the left and the right frame of the camera, and we'll ask some questions around it. We'll see how do you access the left and right frame of the camera. As you know that there are two cameras here. The left camera is for, these two cameras form the stereo pair, and then you can use the stereo pair to do stereo analysis. And you can also get the depth out of this. But first, let's see, how to access these two frames, and then we will show how to actually combine the two frames to get depth out of it. And we are going to display the results. Just seeing some of these things, it's actually very educational if you're a starter, if you're starting out. So now, a lot of people get confused, especially who have never used a hardware before, who are new to programming a hardware. They may be thinking that, oh, how does this work? How do you connect these things? And I had the same kinds of issues when I was starting out. very simple things. Where is the code running, right? Is it running on the device? How is it connected, right? So
Or even what parts of the code are running on which device. This
on
was,
which device?
this was an issue when we did the campaign last year when we
Yeah,
were pitching to the press, like TechCrunch and these
right.
other outlets, that, getting that past that cognitive hurdle of what's running where and what does that even mean to the non-computer vision expert was pretty difficult.
Right. So yeah, so the first step is to know that, if I'm showing you OpenCV AI Kit with Depth Lite, OGD Lite, and it has only one input. There is no other, you cannot go wrong. And it's a USB-C input that you connect your USB-C laptop to, and it just gets connected. And once you do that, it gets all the power through the USB-C input. So there is no power outlet, input, nothing like that. So once you connect it to your machine, which is the host, it could also be a Raspberry Pi, or it could be your laptop. The only thing is that it has to have a USB 3 connection so that it can draw enough power to power the device, and otherwise, it may not work. Now you install DepthAI, and Phil, can you share the docs for?
I already did.
Oh, great. Okay, so that's how you install DepthAI. Basically, pip3 install DepthAI, and you will be able to install that on your machine. If you go and look at the documentation, we have been doing this for a while. It takes less than 30 seconds. If you are a programmer, most of the things are already on your machine, and the installation will take about 30 seconds. Right?
Yeah, last year it was less than a minute. Now we're down to 30 seconds.
Right. Now let's look at what's happening on the host. When I use the word host, it is your computer or a Raspberry Pi where you're running which is connected to your camera. And I may use the word device to mean the camera sometimes, OGD, OGD Lite, these are all devices. Your computer is the host. All right. So the first thing is to build a pipeline. What is a pipeline? A pipeline is nothing but a collection of nodes. And a node is essentially an entity with an input, an output, and some configurable parameters. For example, the left camera is a node, which has an output. It outputs the left camera frame. Similarly, the right camera is also a node. The RGB camera is a node. The left camera and the right camera, they can combine into another node called the stereo depth node, right? And then there are some nodes for interacting with the host. So those are called X-Link nodes. So whenever you see X-Link, it means that we are going to communicate with the host. The camera is going to communicate with the host through this link. It could be an input X-Link or an output X-Link. But let's get started so that these things become more concrete. So I have written some piece of code here on the right-hand side, and this thing is executing on the host. Okay. Now, if you want to start a mono camera, right? We just define mono equals pipeline.create mono camera. So you have an instance of the mono camera on your Python code. It doesn't mean that we have activated it on the device yet. This is just a schematic showing that this is the mono left camera. And you may be thinking, for people who are new, if you're thinking, what does mono mean? Stereo means two. Stereo, when you say stereo audio, means two speakers, left and right. Stereo vision means you have two cameras, left and right, for doing depth. And mono is one of those two, right? Some people may also think that mono here, it's for grayscale, but that's not exactly right. Even though the stereo cameras are grayscale cameras, we don't need color for depth perception. So, okay, so we created, this mono, and then we use this code. It says mono.set board socket. It's slightly cryptic. I wish slightly different words had been chosen, but that's fine. So this is the way to say that I want to access the left camera. So here, what has happened internally, an Xlink in node has been created, which means that now we can communicate through this node with the left camera. And this thing is not visible to you, it's behind the API, but internally, this is what has happened, that we have created an Xlink. And through this Xlink, we can set some parameters for the camera if we want. We can set the resolution of the camera. We can set all kinds of things, maybe the FPS also. So that has been created. Now we do an Xlink out because we want to get the frame out. So we have to create an Xlink out. And as I had mentioned before, Xlink is the node we use whenever we want to communicate with the camera. When the host wants to communicate with the camera, we need to create this Xlink. And we created this node, and we also set a name for this node because later in the code, we are going to say that, oh, I want to get this node. There could be multiple Xlink out nodes. And so we have to specify very clearly which one are we communicating with. And that's why we have set a name for the output node. Okay. Now we will link the output of this camera, which is mono.out.link. So this output gets linked to this xout, the input of this xout. And as I had mentioned before, every node has inputs and outputs, right? And some of these nodes can have multiple outputs. So here, Xlink out has a single output. And with this, we just connected the two. Now, even though I had shown this thing, as if things are happening on the device, actually, I had simplified things. The things were not happening on the device. All this code was running on the host until this point, right? Until this point, I have defined the pipeline, but I have not uploaded the pipeline to the device. The device doesn't know that you have created this pipeline. But with this, I have activated the device. I'm saying that, okay, DepthAI.device, upload the pipeline. I'm uploading the pipeline to the device. And now the device knows the structure of your pipeline, okay? And we get an instance of that device so that we can now communicate with the device. So this is the line where the code that you have written, the pipeline that you have created, actually moves onto the device. All right. The second thing to note is that this output, Xlink out, is implemented as a queue. It is not a single output. And the reason to do this is that many applications may need the last few frames, right, or the last few outputs to do the to perform the task. An example would be, suppose you want to do video encoding, which OAKD can do on the device itself. So it will produce 4K encoded video for you. So it means that you can record a video even on a Raspberry Pi, a 4K video even on a Raspberry Pi. So for those kinds of operations, you need a queue. You need to save the last, let's say, 30 frames to do those operations. Otherwise, you don't have enough frames. You need more frames to do the compression, right? So that is why it is a queue, and you can specify the length of the queue, which I will show in the next demo, how to specify the length of the queue. When we're just grabbing frames, we can specify the length of the queue to be 1. But here I'm not even showing that. So
are there performance reasons you might want to do that, or why would you want to set the queue to be a specific size?
Yeah, performance reasons, and also, how much. So suppose you are using something that it's very computationally expensive, right? But you don't want to lose out frames. You want to keep the frames, right? And something computationally expensive, so it can gather some frames, which is fine. And you hold on to the last frame. You are processing the last frame and just filling up this, queue. And that's another reason to actually have a longer queue. But so if you're just
resource constraints as well.
For resource constraints as well, right? Or sometimes you may want to, for some tracking application, you may want to have a queue because you want to use that frame later on, things like that.
Sure, you can look backwards and see, yeah,
Yeah.
for posing and tracking, sure.
Yeah. So to get the last frame out from the queue, you just do frame equals queue dot get, right? So you get the last frame. And this frame is not in OpenCV format, right? Because it's their internal format. So to convert this frame into OpenCV format, we use this function, frame.get frame, CV frame. I have actually asked the team to see if we can make it get OpenCV frame so that it's very clear that we are getting an OpenCV mat. But for now, this is the name, get CV frame. And once you get the CV frame, it is an OpenCV frame. It's a NumPy object which you can display just like any other image, right? So this will allow you to display the left image, right? And you can do the same thing for the right camera. You can build this pipeline for the right camera, and now you have the two things, right?
That's one of the powerful things about this to me too, is that if you already know some OpenCV, you almost already know how to use DepthAI in a way, which is pretty cool.
Yeah. So let's see how. Okay. Yeah. So let me show you the code. Okay.
Got it.
So you guys can see the code?
Yep.
Okay. Yeah, so let's just repeat one more time, but with two cameras, right? Here we are defining the pipeline, as you can see. The next is I'm setting up the left and the right camera. And here I'm using this get mono camera. I've written a function. Let's go over the function. It's a very simple function. It takes in the pipeline, creates a mono camera. And this was not mentioned in the previous slides because I just wanted to keep everything simple. But you can set the resolution of this mono camera. And in this case, I have set it to 400p. Any guesses why it is called the 400p? This is not the, this is not the prize question, but why is it not just called 400p? Why is it called the 400p?
I don't know.
I mean,
tell us.
Anybody from the audience?
No, you stumped them for the first time ever.
Go check out the naming convention of Python, variables and things. So
there you go. Seth Johnson here. You can't have a number as the first letter in a Python variable.
That's right. So that's,
or I guess this would be a constant in that case, right?
Yeah. So that's why they have used this, this one. D had to be put in place. Anyways.
Well done.
Yeah, so you set the resolution, and there are a few resolutions. You can do 800p, you can do 720p, etc. And then based on whether it's the left camera or the right camera, you choose one of them, right? And it just returns the camera. Very simple piece of code. And then we also have to create the X-link out for both the cameras, the left and the right camera. We have to do the output link. So here we have set the name to left and set the name to right. And if you remember the slides, we still need to attach the X-link out to the input, to the output of the camera. So here, that's what we are doing. We are attaching the left camera to the left output and so on. And then we upload this to the device, right? This pipeline gets uploaded to the device, and we try to find the queue, right? There are two queues, the left queue and the right queue, corresponding to X-link out and X-link, left and right X-links. And this one is simply,
and in this case, we're explicitly setting the size of the queue. I notice
right.
as well on line 51 and 52 there.
That's right. I missed that. Thanks. So max size is setting the size of the queue. There's another variable here that we could have set, which is called blocking. So blocking, what it does is if it is set to true, then it would actually override. If the queue becomes full, then it would override the queue, the last element in the queue. And if it is not, actually, I might have just said it the opposite. If blocking is set, then it doesn't override. And if blocking is not set to true, then it overrides. But for this purpose, I just wanted to keep things simple. Now we have created the stereo pair, window for displaying the stereo pair. And from now on, this is very simple, right? I use the queue to get the frame, and get frame is actually very simple. I get the frame from the queue and convert it to OpenCV format so that I can display it properly. All right. And I have the left frame and the right frame, and this variable controls whether it's a side-by-side view or it is a merged view. And that's it. Let me quickly show the demo. And then we'll go over
Quick
so I'm just running this code.
Audience is this a last in, first out queue? Or is it a first in, first out queue?
It's a first in, first out. So you can see the screen, right?
Yeah, we can see the stereo view here.
Yeah, and it looks almost the same, but I've carefully arranged the mic so that the mic, you can see the differences. It's one of those
spot the difference.
Spot the difference. When as kids we used to do that. So you can see that they are not the same. They look very similar, but they are not the same. But here's the interesting part, and this would be fascinating for people who are starting out. Especially my 11-year-old son. How do two cameras help you estimate depth, right? And this view nails it. So for example, my face is much closer to the camera than the door behind me. If you look at the door, it is very much aligned. Let me see if I can actually get a door knob or something. Okay, if you look at the knob of this curtain rod, they are pretty much aligned. They're slightly different, but they are kind of aligned. But if you look at my face, they are very far apart, right?
There's more disparity the closer you are to the camera.
Exactly. So that word is called disparity, that the corresponding pixels are far apart for closer objects, and they are very close together in faraway objects if you look at stereo vision. And that's how it works. There is a multiplier which is related to the focal length, and based on other camera parameters, there could be slight changes, but mostly there is a multiplier which would tell you that this disparity is a measure of depth. It's an inverse measure of depth. Things that are closer, that they are far apart, and things which are close together, they are far apart. So I think this view is very educational for people who are starting out, and these kinds of things. It was just to get a view like this, to get a stereo view. It's not easy to set up things so that you can easily get the stereo view like this, right? So
just a couple of years ago, this would have been many hundreds of lines of code, if not like 1,000.
But more importantly, it is not in. You'll have to set up two cameras, and it's a real pain to get rectified views, right? So that's one thing I wanted to cover. Does anybody have any questions so far?
Yes, a couple. Do you know what the max queue size is for DepthAI?
I don't know the max queue size, but I know that 30 is used by default.
Okay.
because they do 4K video encoding. If you don't mention anything, it is 30.
Is the frame queue memory managed on the host or on the OAK-D?
No, everything is managed on the OAK-D, right? So the OAK-D is responsible for doing all of that. I can ask Brandon for confirmation, but I'm pretty certain.
Okay. Those are the main questions so far. So Zach here wants to know, is there a reason there's not a built-in OpenCV code for this scenario? Like just, get stereo frames, camera one, or something like this?
Oh, yeah. So there is a DepthAI SDK that is being built, which will do all this thing for you in a much simpler way, right? But I also wanted people to get a sense, get their hands dirty with the low-level API, right? This API, so there is an SDK that is being built, and I'm pretty certain that it will be ready in a couple of months when people start getting their OAK-D lights, which is exactly that kind of abstraction where it's very easy. But it's also good to get your hands dirty with the low-level API just to see what's going on, and then you can always use the high-level API, to save time. But it's very important to know what's going on behind the scene, because something or the other will go wrong, and you shouldn't be banging your head against, oh well, I just don't know what's going on, right?
Yeah, absolutely. One of the biggest problems, and I think misunderstandings people have with computers currently, and how code for them works, it's impossible to write code that doesn't have bugs in it. It's just impossible. No one has ever done it. And so having that lower level understanding, it's not going to help you up front. It's going to take a little bit longer to write code in this fashion, but once you understand it, when something gets broken, you have much stronger tools in your brain to figure out why it's broken.
Right. Okay, so how much time do we have? Oh, we have enough time. I can go over the second demo.
We got plenty. We got half an hour left.
Yes. So let me go over the second demo. Let me show you the demo first, and then we will see the code. Okay, so here what I have done is I have combined those two stereo views to get the depth estimate. Right.
Can you explain the color gradient, which why things are the colors they are?
Yeah. So what you're looking at, the disparity. So in DepthAI, you have the option of getting the disparity map out, and I'll show you in the code how it is done. And what you're looking at is a color-coded disparity map, where it's basically a color map. This color map is called the jet color map, where things that are far away or things that are smaller in value, they are colored blue, and the things that are close or high in value, the things that are high in value are actually red. So you can imagine a color, based on temperature, that cool things are small and hot things are big, right? So here you can see that my hand is red, completely red. And the things on the back, they are not as good. Now,
it's a pretty good view of the range currently, because I know somebody's going to ask the operational range of OAK-D, Satya. What are the suggested min and max distances here?
Right. So the min distance is a little over a foot, I think, and I can show you the demo. This is the best thing, when you write your own code. Here. So still, it's all doing good. Aha. So I have violated the minimum distance, right? It's a little over a foot. I have the exact number.
Yeah, I think they say 30 centimeters, right? Something like that.
Doesn't look like
30, 35, maybe.
Yeah, it doesn't look like 2 feet to me. Oh, you said 30 centimeters. Okay. Yes.
Yeah.
That's about right. Yeah. Okay. So you can see that it violates the minimum distance, right? If you're ready for the question, if you're ready for the question, right? Here's my question.
Is
You see
this
that
trivia? Is this for the Oak D light?
this is for the Oak delight.
Okay, everybody get
Question
ready.
is coming
This is
in
important.
the middle. There are two kinds of problems when you're estimating depth. If you look at my fingers right now, around my fingers, right? So this is a two-part question. Around my fingers, you can see that the depth is wrong. Right here. Can you see? Around this.
Yeah, there's almost like an outline.
There's an outline where the depth is incorrect, right? And we actually put it, we say that it's incorrect, right? And I can actually show you, okay, I'll show you later on, why. So that's one issue, right? Why is the depth incorrect when don't write the answer yet because it's a two-part question. Why is the depth incorrect when around these edges, right? And just to give you an idea, it can be really incorrect, right? If I tilt my hand like this, there are large portions which are incorrect, right? Okay, so that's question number one. The second question is, the depth is also incorrect when I move this, right? So what are the reasons for those two incorrect depths? There are two different reasons. They are not the same reason. The first one is for a different reason, and the second one is for an entirely different reason, right?
Have at it, chat.
You can do, you can start with the first one. Why do you think the first one has incorrect depth?
Some good answers here, I think. Let's see. Do you see the right one yet?
I actually am not looking at this.
Look at the chat. Yeah, look at the chat. You're gonna have to call it. I don't know what the exact phrasing you want here.
Okay. 1 second. Let me look at the chat.
Go up to 933. I think Seth answered the first one. I don't believe it's correct, but that's where the answer started.
Is it in the Q&A or is it in the chat?
No, just the chat.
Okay.
If you click the chat button at the bottom of your screen, you'll be able to see it there on the Zoom window. Exciting content, I know.
Okay,
everybody.
I think I have seen the right answer, at least in one of them. So I'm going to tell you the right answer.
Okay.
And then people can, you can find who gave the right answer, right?
Yeah, I'll have to go through the timestamp because there was a bunch of answers there. So.
All right. So the first reason why the depth estimate is right, because one of the cameras cannot see this piece, right? When I tilt my hand, both the cameras are able to see most of the palm, but not all of it, right? So on the sides, there are pieces which both cameras cannot see. And so the technical word for that is occlusion, that it is self-occluding. The camera cannot see every part, so you cannot triangulate. Stereo vision is based on triangulation, right? It triangulates. If you know the position of the same point in the two cameras and the cameras are calibrated, then you can know the depth of the point from the camera. You can know how far the thing is from. So this was a result of occlusion, right? But now let's go to the second piece, right? Here, nothing is occluded. Nothing is occluded. My palm is clearly visible to both the cameras. Now, why is it not giving the right answer?
Have at it, chat.
All right.
So
somebody said you're in a dead zone. That I want more explanation, right? I want what does it mean? More
why and less what?
Yeah, it is limited by the distance between the cameras, but what exactly, actually, it is not entirely limited by the distance between the cameras, but what exactly? Okay, I think we got the answer. This answer must have, probably it was answered before also, but I just want to make sure that, the right person gets it. You will find the person, right? The right answer is, to find, let me show you a demo, right? And then we will go to the right answer. So here on this application that I have built, you can actually click. Okay, so I clicked on this rod, the knob of this rod, and I just drew this line all across, right? It's fascinating. I mean, the first time I saw this demo during grad school or undergrad, I was fascinated because, you see, you may think that this calculating the point, for calculating the depth of a point in a 3D scene, you need to know the location of the point in both camera views, right? So this knob, if I want to find the position of this knob, then I want to know where this knob lies in this picture, right? It may look like it's a 2D search, right? You have to search over the entire space to find where exactly this point is. And you can take a block. If you want to do it naively, you can take a block around this patch and then search in the image where that block is. It looks very similar because these are very similar views. So you may try to do a search and see where this block matches. But fortunately, the smart people have figured out that you don't need to do a two-dimensional search. You can rectify the images, and what you're looking here are rectified views from the two cameras. And when you do image rectification, all corresponding points lie on the same scan line. So what it means is that if I'm looking for this point, I don't have to search over the entire image. I just have to search for it over this scan line. Isn't that beautiful?
Basically one-dimensional.
It is one-dimensional, right? It speeds up. Now you can have blazingly fast stereo depth estimation, right?
Computationally, it's not even just 2x faster. It's considerably faster than that. Yeah.
It's squared, right? It is. Otherwise, so suppose your width was 1000, right? Now you have to do a 1000. Let's say you're searching at every pixel. Then you would do a 1000, you will do the calculation 1000 times. But suppose you did not have this knowledge, then you would do the calculation 1,000,000 times because it's 1000 by 1000.
1,000, right? Yeah.
So, so this is called image rectification, and DepthAI does provide you the output. If you want to look at the rectified views, you can look at the rectified images as well. And it's not that just that knob. You can pick pretty much anything. You can pick this shirt, right? The end of my arm. You can put, you can pick any value. It lies on that scan line, and that's why stereo depth is, it can be blazingly fast, right?
Yeah, tremendously useful solution to the problem of this. Yeah.
Right. So when I said that, you could search for 1,000 pixels, I lied a little bit. That's not how people do it. The reason is that searching over 1,000 pixels, it's still a lot of pixels, right? So what you do is, let's say this is some value, right? I'm just, let's say, 100 by 100, right? That's the location. Location X is 100 and location Y is 100. You don't search for all the pixels along the X equals 100. You pick a window. You say that it is this. Let's say you could say that I'm going to search for only 100 pixels along the X direction, negative X and positive X, right? 100 pixels on both sides. That is called the window over which you're searching, right? And the closer something comes, the disparity becomes larger, right? And so if you have set that I'm going to search for only 100 pixels across, you are not going to find the match, right? And that is what happens. So when I bring my hand up to this level, it is still within the disparity range that we are searching. And if I move it closer, then we lose it, right? And the question is there a way to change that? DepthAI does provide a way to change that to half. So you can change the disparity. It's not a continuous scale. You cannot set the value to anything, but you can set something so that the disparity becomes half, sorry, double, right? I meant so the distance that the minimum distance becomes half, but the search space becomes double. The challenge there is, anybody, what would happen?
Anybody in chat?
Yeah.
Stefan says speed.
Yeah. So obviously when you're searching over a large space, the frames per second would decrease, right? But in certain applications, maybe that is what you need, right? You need to be able to see closer objects, and the price you pay for that is speed, right? So I think we still have time to go over the code for this particular demo.
Got about 15 minutes. Yep.
Yeah. So you found the winner?
I haven't had a chance to go through it yet. There's enough answers that I don't want to. Okay. I don't want to say the wrong person here.
Right.
So we'll have to be in touch after the show with our winners.
All right. Let's see. Is this useful at all? I mean, I want to get some feedback on people who who missed. Who did not. We know that today's guest canceled, and we put together this tutorial. Is this useful at all? Is it a waste of time? Any feedback would be good.
Yeah, what do y'all think? Seems like people are pretty into it.
All right, so that's really good.
Yeah, thanks everybody.
I like that it's not wasting people's time. Okay. So the code is very simple, as before, because
Priyesh says they like the tutorials better than the guests. Thank you.
All right, so the code is, I'm borrowing on the old code that I had shown, so you will still get the mono camera, and you also have I'll create another node called the stereo pair. Let's see. So this mouse X and mouse Y is basically, I'm tracking. You saw in this demo, I'm clicking on a point. So this is to actually track that point. So again, we set up the pipeline. We set up the left and the right cameras, and then we create a new node. This is called the stereo depth node. And here I have created a function so that the left and the right cameras can be attached to the stereo pair. So, as I said, that the stereo depth is also a node, and we can attach that node to the pipeline by using this piece of code. It says create stereo depth. And as you may imagine, that the stereo depth requires two things, the left camera and the right camera, right? So it requires two things. And that's what you see here. We are linking the left camera and the right camera, and that's it. It's input. It needs two inputs, the left camera and the right camera, and the output would be a depth map. And there are actually several outputs for this node. One of them is the depth map. The others are rectified stereo views, and there are others as well. We will see.
Yeah, another question quickly was somebody asked about the cameras themselves, and part of the reason this works and is so smooth is because those are a matching pair of the exact same camera with the same specs, same focal length, and they're arrayed in a specific distance from each other, which is called the baseline. And Satya, would you like to maybe quickly just describe like how having cameras closer together or farther apart affects the depth?
Yeah, so basically, if the cameras are far away, it also means that you can look, the depth that you can look at is going to be far away, right? The reason we chose this particular setting, it is 7.5 centimeters, is because is because of human eyes. Oh, you already, yes. Yeah, it's close to human vision. So that's why it has been put like that. It's not totally true though. I mean, it's close to human vision, but these are also static cameras. When we look at things, we don't look straight always like that. We can twist our, like this. You can almost focus on this thing.
You can make your eyes all googly.
Yeah. So the wider baseline means that you can look farther, the depth would be farther, but there is a caveat, right? The search also becomes more noisy, right? Because things start looking different as you move the camera baseline farther away. Things start looking more different, right? Because of viewpoint changes, etc. And the basic premise of stereo vision is that things look similar in the two camera views, right? That is why you are able to match pixels. And if they start looking very different, then it's not going to work. And for the same reason, stereo vision doesn't work when you have shiny objects, right? If you have, it will work very well on cement like things or cloth, because they reflect light equally in all directions. And those kinds of things are called Lambertian surfaces, after Lambert, who was the scientist who came up with this kind of model. And Lambertian surfaces reflect light in all directions equally, but a lot of things are not Lambertian. For example, shiny plastic is not Lambertian. Glass is not Lambertian, right? They reflect light unequally. They depends, when light falls on it, you will see a specular highlight. Where, along the direction of every light, you'll see a highlight. So for those kinds of things, stereo depth doesn't work well. In fact, almost all stereo algorithms, no matter what kind of sensor you use time of flight sensor, etc. Whatever you use, they are not good when you have shiny surfaces. Yes. Okay, back to my my tutorial. Now
and the other issue too, is a couple of people have said in chat here, asking about low light conditions. So one of the things with with OAK-D specifically is that it's using visible light instead of, say, like lasers. And so if it's pitch black outside, you're just not going to be able to get features for the camera to see. So it'll kind of fail in that scenario.
Right. So the other kind of stereo vision is, there are three or four different kinds, popular ones. But another popular one was the one that Connect One used. Connect One used what is called a projector camera system. So you have a stereo system. There also you have a stereo system, except that one of the cameras is not a camera, it's a projector. So, its job is to project some pattern onto the scene, which makes it very easy for the stereo camera to do the matching, right? So, and these two pieces are calibrated, so you can actually find, oh, this is the pattern, I know the pattern, and this is where it lands. And because the whole system is calibrated, you can know what is the disparity, even though one of them is not a camera, right?
Right. The camera knows what the pattern looks like when it's flat, and so it knows how it's distorted. Exactly.
Right. And so the matching is done on the camera. So that's called a projector camera system. Another one is a time
similar. It's the same as my old friends at Occipital with structure sensor and structure core.
Occipital also does that. And then the final one is a time of flight sensor, where you literally measure, how much time is spent. And so those are the three kinds. They have all their weaknesses and strengths. For example, the projector camera system, they are usually based on infrared light. And if you take them outdoors, it's just not going to work, because they cannot project the pattern they are looking for.
It's not going to be able to compete with the sun.
That's too bad, What if you use a much higher powered one,
Just high enough to blot out the sun. Yes.
Right. Okay. So those were a few things. Now let's go back to the code, because I do want to finish the code in time. So here you can see this line of code. It says set left, right, check. It's an interesting one. The thing is that you remember in the first case, I showed that, let's actually run it. I'll actually not set this and see what happens to our depth estimates. It's coming up. Where is my, okay, here. Okay, so now you remember we were seeing a black line, black shadow around this. Now you're just looking at noise, right? So if you don't set that parameter, it is actually getting the wrong depth. It is, in the previous case, it was the wrong depth, but we knew it was wrong. And so we were setting it to a specific value, which indicated that it is the wrong depth, right? I think we were setting it to 0 or something, which indicated that, oh, that's the wrong depth, right? But here we are not doing that.
Was it 0 or was it nan?
I don't know for sure. Maybe it is 0 because you cannot have 0 depth, right? But here you can see that, it is incorrect because we are not doing that check. That check does take some extra time, but I think it is worth it. Otherwise, for many applications where speed is of essence, you may want to turn it off, but usually, it's a good idea to turn it on. So that's what this code does. Okay, so yeah, so we basically added a stereo pair, stereo depth node using this very simple, lines. It takes the input, the left input, the right input, and outputs the depth map. But let's see what are the various things it can output. So here I have created a node for disparity. I've also created another output node for rectified left, and another one for rectified right. And you can look at, these are not the only ones. There are several other, let me find this. There are several other DepthAI stereo depth. I'm sorry, I'm doing this live search for this.
Thrill as Satya searches. Chill as it takes him a while to find what he's looking for.
Oh, I found it, not that slow. Okay, so if you look at that node on this, you can see this is what the node looks like. It takes in the left, right, and it can have several outputs. We are only looking at the rectified left, the rectified right, and the disparity. Once we do that, we are able to, show that demo. But in case you're looking for other outputs, this is the total list of outputs. You can get the actual depth in, I forgot the unit. Maybe it is in millimeters or centimeters, I don't remember. But you can get the depth also. But for us, display is more important. So we are outputting disparity. So
makes sense.
Yeah, and that's pretty much it. You can basically go through this. We are showing this, rectified. Whatever the stereo output does, the rectified stereo output is piped into that output link. And this, this code, I will share this code with you, but from here on, it is pretty straightforward. We are creating the depth queue, we are creating the disparity queue, and we are simply displaying the left and right. And we are also, measuring where the mouse was clicked. And based on that, we are drawing a line wherever the mouse was clicked. I've not removed some of the hard coding, but that's okay. Sorry about that. But I'm basically drawing a line through wherever I clicked on it through the whole thing. And yeah, so simple piece of code. The more important piece was the demo that I showed you about, how image rectification works. What is image rectification? Basically, you take two images from a stereo pair and transform it in such a way that that the corresponding points lie on scan lines, on the same scan line. And fortunately, it is possible. That's a good thing to have. The second thing that that was important in this was the fact that there is a disparity search that people do. The stereo vision algorithm does, and if you are not within that range, then the depth would be incorrect. And the final thing was occlusion, that if things are occluded, then the depth would not be right at that point. Other than that, we went over the DepthAI pipeline, the concept of pipeline, the concept of nodes. I'll share this code after, give me a day or so, but I'll share this code with you to play around with.
Excellent.
So that is it. Good to know the feedback that people are enjoying these tutorials also. So we may want to do more of these.
Yeah, you're a hit, Satya.
Thanks.
The people love you.
Thanks.
We've got time for a couple more questions. I think with about 3 minutes left in the show here. Got a question from Richard Chen. If the camera is tilted, will the single horizontal line scan function work? And obviously no, right?
No, that's the beauty of no matter what, how you tilt the camera, it doesn't matter.
We have to get the rectified image, right? You
have to get the rectified images. Yeah. And that is output by the camera. You don't have to do anything. The camera does it. Yeah. So the rectification basically is depends on the geometry of the two, how the two things are specified. But this is a factory manufactured camera. There will always be some irregularities. So you cannot make a perfect camera where everything is rectified out of the box. You can get lucky and they would be rectified in this configuration. But there is always a software step that is done to do a better rectification, because you can imagine for faraway things, a 1 pixel change in value in disparity can mean a lot, right? It's going to give,
especially at the very close and very far. Yeah, that makes total sense. There's also a way there's a tool so they come from the factory calibrated, right?
Yeah.
But there's also a tool because through use, your camera is also going to get jiggled around and stuff. And those very precise calibrations can change or need to be changed through heat or cold or just all manner of things affect cameras. Right. And so you can recalibrate them. There's a tool to calibrate yourself, right?
There's a tool that the DepthAI API provides to calibrate it. And the tool also provides a check whether, the calibration is good or not. You can read up on it. It's called reprojection error, that it will calculate, where the point should go in the camera. And we also can detect where the point actually is in the camera view. And if they don't match, your calibration is off.
Which is cool. It's basically checking up on itself.
Yeah, I just saw another question which I want to answer. Can you combine multiple cameras, increasing the baseline and the distance? Yes, you can, but then the processing may not. You'll have to write some custom code to do the processing and synchronization, etc. The good news is somebody has also, there are 3 cameras actually on OAK-D. The middle camera is an RGB camera, and then there's a pair of
4K RGB camera.
A 4K RGB camera. And somebody from the community has already written code where they get better estimate by using trinocular vision, not binocular vision, not stereo vision, but using all the 3 cameras to get better estimates. So,
open your third eye, people.
Right.
So I see another question here about, are we using any AI for depth estimation here? And are there functions that use AI specifically to estimate depth?
That's a great question. So, there's this thing called semantic segmentation, which segments out people, things, etc. So there is also quite a lot of literature where you can actually do monocular. Using a single image, you can find the depth of the scene. And that is based on training on similar scenes, right? And then there is this concept of semantic segmentation where you segment out people, etc. So those two concepts, you can use AI. And in one of the demos, I believe in DepthAI examples, there is one example where we are combining the two things, semantic segmentation and depth analysis, to give you a better depth estimate. So in this, out of the box, the depth is pure computer vision depth. It is not using any AI. But you could write, because there is a neural inference engine inside, you could write something that would combine all of this information.
And theoretically get, higher accuracy.
We have some example code, at least some working example code that somebody from the community has already done.
Yes, indeed. I'll just do one more here. So many questions today.
There's another question that just caught my attention. Does fog and rain impact the depth accuracy? Absolutely. It's like human vision in some sense. Whatever affects your depth accuracy, it will also affect the accuracy of the camera. When you cannot see things, it will affect accuracy.
Yeah, that makes sense. Especially again, and even if you were using, say, like a laser-based system, fog and rain will also affect those, because water basically functions as a prism. If you're shooting lasers at a droplet of water, it's going to affect the pattern. It's not going to be the same as putting it against a solid surface.
Yep.
All right, we're about 5 minutes past. You want to take us home, Satya?
Okay. Yes. Thank you so much, Phil, for helping out with the organization of this thing.
Yeah.
And thank you so much for everybody who joined today. We couldn't have the guests, but we still had a very lively session. So we will continue with this idea. If any guest cancels on us, we will just wing it.
Yeah, I think it went great. As they say, the show must go on. Our guest next week will be Bart from Team American Stereotypes, who made this awesome VR laser tag system for OpenCV AI competition. Really looking forward to it. I may be able to set it up here at my apartment, and so maybe we'll do a brave live demo for that, but no promises. That's great. And last plug, OpenCV AI Kit with Depth Light is on our Kickstarter campaign right now. Which you can go to opencv.org/Kickstarter. And there are a ton of tutorials like the one I'm creating for people who want to get started. So be brave if you're thinking that, oh, I have never used this camera and things like that. Don't worry about it. We will make sure that you will have enough resources. As long as you know Python programming language, you should be good. And my goal is to make sure that my 11-year-old is able to use this this camera and the code. That's why I'm writing this. Yeah, and if it's easy enough for Satya's 11-year-old to use it, then even I might be able to figure it out. So it's important. While we're doing plugs, there was one more question. Would you like to tell people what the best way to get started learning OpenCV is, Satya?
Yes, another plug. We have OpenCV courses, official courses by OpenCV. You can go to opencv.org/courses. We have a series of courses. Computer Vision 1 is an introductory course in computer vision, very hands-on, very practical, lots of applications. And we also have a deep learning course called Deep Learning with PyTorch. I highly recommend both of these courses. Another one, Deep Learning with TensorFlow and Keras, is coming early next year.
Awesome. Right. Yeah, thanks everybody. We'll be back next week, Thursday, 9 a.m. Pacific time, same bat channel. Take care out there. Thanks so much for watching this episode of the webinar. Please hit that like button, subscribe, and don't forget to tap the little bell icon to be notified when new episodes drop. This episode was brought to you by the all-new Oak D Lite, currently available on Kickstarter. If you'd like to be in the audience next week, subscribe to the OpenCV newsletter.